another episode of Down in the Lab with Doug. Today I'm going to be using the Arduino Uno and I'm going to be talking about the potentiometer, which is also known as the variable resistor. If you don't know what that is, it's simply the volume knob on a radio. Let's get started. Okay, before we actually get started, I want to draw your attention to the upper right hand portion of the screen so I can explain this, and it's going to help you better understand it as I explain it further down the road. You're actually looking at two different circuits here. This side of the circuit is hooked up to the Arduino, and this side is not. They're both independent. This one has its own 5 volt, this one has its own 5 volt. These are both the same circuit. I have a potentiometer with a 5 volt signal going to two LEDs. I have a 5 volt signal going to a potentiometer with LEDs. The difference is one, of course, one's hooked up to Arduino, like I said, but one's blinking and one isn't. And one of the things that a microcontroller does, it can do stuff from analog and convert it into digital. And that's what we're going to be talking about later on here. And that's one of the magic things about this. It can take an analog component, like a potentiometer, read it, convert it into a digital signal, and do something different with it. Like here, we're blinking the LEDs, but it even goes further than that. And let me explain that. Okay, now if you draw your attention to the code, I'll run down this code and I'll explain this pretty fast. We have two integers. One's called sensor pin 0. That's the analog 0. That's where we actually are going to take the one pin from the potentiometer over to the Arduino. And the other one is pin 13, which is going to connect to the LED. I put this in here for serial output, and I'll explain this again later. This has helped me troubleshoot it. I'm assigning this pin to output, so pin 13 output. Here's where the analog 0 portion, this pin, there's 6 different pins here, but they're all analog, and what that can do is it takes an analog component and it can actually read it and then modify it into a digital signal. And what I'm doing is I'm creating an integer here. I'm calling it sensor value. And then saying it's equals to analog read. That is a special function in the Arduino. And I'm assigning it to that sensor pin 0. What that analog read function does is you have 0 volts to 5 volts. It then converts that to a binary number, 0 all the way up to 1023. And if you're wondering why 1023, it's because it's binary. It's actually 0 counts as a space, so it's actually 1024. So if you would divide that down to 512, you would have 0 volts, and it would be 2.5 volts, and that would be equal to 512, and then 5 volts, and that would be equal to 1023. And of course, 0 would be equal to 0 on that side. And that's what this analog read does. I'm taking that number, and let's say if I have it halfway, it would be 512, and I'm assigning it to this integer called sensor value. I'm actually, this section right here is me printing it to the screen again for troubleshooting. And in order for me to take that number and convert it back to show me what voltage it is, just for me to troubleshoot on the serial monitor, I actually can bring that up right now. Yeah, you can see that. Yeah, so I'm actually taking, and it's a float variable, and that's a different type of variable that has decimals after it, and it can change. Anyway, I'm cleaning up full voltage, and then I'm taking that sensor value and I'm dividing it by 1024. Remember when I said 0 actually counts as a space? And then times it by 5, and that algebraic equation will then reconvert that back into volts so I can display it on the screen. This part right here, hopefully you guys are picking it up right here from our very first video when I showed you how to blink an LED. I'm digital writing the LED pin and I'm setting it high. I'm delaying it, but if you notice the number, if you go back to the first video, I don't have a number in here. I have the sensor value. So this value is going to change every time it goes through this loop. And I'm going to demonstrate this over here on the circuit. So you see this blinking right here. So when I change this sensor value, let me put the sensor value back on the screen for you so you can see it actually change. There we go. So I get my hand in here and I change this. You see it blinking faster? There we go. You see the value of 49, it's really low. I get it to 0, it's 0 value, like I said. I wonder if I can get it to 5. If my hands are good enough to get it to 512. Oh. Almost. You saw there 513. It's touchy. Well, you see there 515, 5.1, so you understand the concept. But that's what it's doing. And I can further demonstrate here. I can take this multimeter here and I can, in the middle here where I said this goes, and if you look, that voltage corresponds to the voltage that you see in the upper right hand corner. I'm using, that's variation. The algebraic equation rounds, so it's on the serial monitor for the Arduino, but that's fine. Not much difference, doesn't make any problems. Getting all sorts of, there we go. So yeah, there you see it, and okay, the thing that I'm showing you here is I actually hooked a multimeter up to this, and you can look at the serial monitor going down through that binary value. This is the line coming over right here going into A0 of the Arduino, and it's assigning it the value of 631. It's dumping that value into sensor value, and then that's what's creating the delay. And if I change the potentiometer, I'm going to change the sensor value because that's what I'm watching, and that's going to change the blink rate, the delay rate, of the LED. Let me go back the other way here. There we go. See, I'm speeding it up. As I drop the sensor value, I'm speeding it up. So if I'm dropping the value, if I wanted to have the potentiometer go the other way, I would just inverse all the numbers in my equation, and I could actually turn the potentiometer the other way to make it go in the opposite direction. See, that's pretty cool. You get to see that. So then on this side, we have the same type of circuit. This isn't, and the only thing, this is an analog, this is the analog, and it's same potentiometer, just a different style. And you can see I can dim the LEDs and bring them back up. Dim them, bring them back up. And if I stick my multimeter over here, and you watch this voltage, don't pay attention to the voltage on here because that's a different circuit. Watch this voltage up here, and you should see it swing as I twist this down, and you should see when I twist it back up here, the LED should brighten and lower. There we go. Brighten and lower. One of the things I'm going to be showing you is the logical layout of the circuit that you see in the upper right hand corner. Hey Trent, can you give me that image?
Sure.
Can I have that image?
I'm working on it. There you go.
Oh, thanks. Okay, so yeah, here's the logical layout of the Arduino board, as you can see, corresponding to the one in the upper right-hand corner. Okay, so there you have it. I was able to show you two different circuits both using the same potentiometer with two LEDs, and how you can take that change in resistance, monitor it on the Arduino, assign it to an integer, then take that integer and then apply it to like a delay function that we used in the first blink circuit, and actually change the rate of blink based off of a potentiometer. That analog to digital conversion. And also, like we talked about, how it being 0 volts to 5 volts, and it starts at 0 and goes to 1024. That's that analog to digital conversion. I hope that you enjoyed this and have a great day.